This is video number 4 of section 2.2, 2.3, the last video of this section. We were talking about the equation of the tangent line being a formula that is pretty versatile because all it does is asks me to have two things: the slope, which will come in the form of the derivative, and a point that has an x and a y. If I can have those three things, I guess they called it two things. The point has an x and a y coordinate and the slope. If I have those two things, I can build my equation using this format. We call this point slope form. All right, let's look at this table. No equation given, just a bunch of numbers. Function h of x is differentiable. We can find the derivative for all values of x. The slope of the tangent line exists for all values of x, with selected values of h and h prime in the table above. Can you write the equation of the line tangent to h of x at x equals 1? Great. I already have my first thing. I already have my x value. This is like my a in my formula. Now I need to find the y value that goes with that. That would be my f of a from my formula. So how do I do that? Well, use the table, and we can see that when x equals 1, my h of 1 is negative 5. That's my y value, negative 5. Now, again, we use f in the formula. This is a different name, so it's almost like I could go back over here to the formula that I wrote at the top, and I could just change these f's for h's because my function that they're talking about in this particular problem is h instead of f. So I could just change it there, and I could just change this, and we'll call this h of a if that makes you feel better. Great, found that. Now we need the slope. I need to know the slope h prime of 1. This would be the slope. Well, h prime of 1, when x equals 1, h prime is negative 4. So I have everything I need. I have my slope, I have my x, I have my y. So I'm ready to write my equation. Y equals the slope of the tangent line, which is the derivative value, times x minus my a value, my input, 1, plus my y value, or my h of a value, which is negative 5. I guess I could write this as minus 5. And right there is my equation of the line tangent to this particular function, which is not given to us in equation form. It's given to us in table form at the point where x equals 1. Not so bad. Can we do the same thing for x equals negative 2? Well, sure. Go ahead and pause the video and see if you can set it up. Identify what is your a, what's your x, what is your h of a, what is your y, and then what is your h prime at negative 2, which would be your slope. Go ahead and pause and then restart it when you think you have an answer. This would be our a. We want to find the y. That would be our h of a. So when x equals negative 2, my h of negative 2 is 3. Now I need to find my slope, h prime at negative 2. So when x equals negative 2, h prime is 0. That's my slope. So I have a slope and I have a point, x and y. I'm ready to write the equation. Y equals slope times x minus my x, which is going to change this to plus 2. And then we're going to add on the y value, plus 3. Except, what's different about this one? My slope is 0, and when I multiply 0 times this parentheses, everything's going to go away, and I'm just left with y equals 3. This is the equation of my tangent line. What does that tell us about the graph? What does y equals 3 look like? If I draw it over here, y equals 3. 1, 2, 3. Y equals 3 is a flat line that goes like this, right? So if this is the tangent line, that must mean that my graph is either, and this happens at -2, that means my graph is either like going like this and it hits it, or it's going like this and it hits it. But there's some kind of maximum or minimum because my tangent line is a flat horizontal line. So that must mean that my graph is hitting either a slightly minimum or a slightly maximum point there. We call those relative mins and relative max. We'll get back into that again, probably in Unit 5. Do we need to know this right now? No, we'll get to that. But it's a good exercise of realizing, oh, if my slope is 0, I'm going to have a horizontal line, and a horizontal line means the curve is touching it either from below or from above, but that also means that there's a maximum or a minimum at that point. Good to know. I'm going to skip number 5 to go to number 6. It says, this is the last question here in this section. The function p is defined by this equation. Write an equation of the line to p of x at x equals e squared. I think this is the last one. Well, let's see. Here's my a. I need to find my y, which would be my p of a, because this function is called p. How do I figure out the y? Well, I could plug my x into the formula, right? And that'll be the natural log of e squared squared plus 7 and figure that out. But if you think about it, it says it's a calculator active problem. I can use my calculator. So I'm going to use my calculator to figure out the y. But while I'm there, I'm also going to figure out the slope. The slope would be the derivative of this, or p prime at e squared. So we're going to use the calculator to figure that out. Okay, so I'm going to go over here. The natural log of x squared plus 7. I'm going to go to y equals, I'm going to erase what's there, and I'm going to type in the natural log of x squared plus 7. That's my formula, right? I'm going to go to my home screen. I need to do two things. I need to find the y value. So I'm going to press alpha trace, because the calculator remembers that I have a formula in y1, and I'm going to say, hey, calculator, can you tell me what the y value is at e squared? Oops, I did a double duty here. Can you tell me what it is, e squared? This is like function notation, right? F of x, f of e, y of e squared. So this is telling the calculator to go to the y equation and plug in this number, and we get this long decimal. So let's round it to the nearest thousandths. So this would be 4.121. Awesome. So this is 4.121 approximately. And then I'm going to find the derivative. Okay, so I'm going to go back and I'm going to say math, and I'm going to go to 8 because that's the derivative. I'm going to put my equation is in terms of x. I already have my equation saved in y1, so I don't want to type it all over again. So I'm just going to say alpha trace, option number 1. The calculator is going to look for the equation in 1. It's going to find the derivative value at e squared. And it's going to give me this long decimal. Again, I'm going to round it to 3 decimal places to the nearest hundredths. So that's actually going to give me 0.240. 0.240. I'm going to put it in the color I got it, 0.240. So therefore, I have my x, I have my y, and I have my slope. I can write y equals my slope, 0.240, times x plus, I'm sorry, x minus my x input, my a value, my e squared, plus whatever the y is for that e squared, which we approximated as 4.121. Using our calculator, we found, and this funky function, right? Like it's a funky function with natural logs and x squares. But using our calculator, we're able to find not only the y value of the function, but the slope of the tangent line at that particular point, e squared, and we can set up our equation. So I'm claiming, and you can do this as an exercise, if you graph this equation and you graph this linear equation, they're going to meet, they're going to touch at e squared because this is the tangent line to the p of x formula that we started with.